compass, the big one is not in my room anymore, but in the compass, you open it to the angle that you want, put a pencil in, and then you would put the point wherever you are, and let's say that the A is right there, and the B is there. Then I would put the point here, open it up to however where A is, and make my pencil do that. Now I have that measurement, and I can do another line segment, and it could be exactly equal. If I open it all the way out to B, then I could do the same thing and mark it. So that's what it's talking about doing. So then you have 4 questions on 1.3C, and we move on to equalities and inequalities, section 4. An equality means they're equal, and inequality means they're not. 2 magnitudes A and B may have one of 3 relationships. A could be equal to B, A could be greater than B, or A could be less than B. It's the only thing it could be. They're the same thing, or one is bigger, or one is smaller. These 3 are represented as, and these are things that you've seen before, either A is equal to B, A is greater than B, or A is less than B. And the way you can remember what a greater than or less than means is think of it as it points to the smaller, okay? So it's opened up to the larger. So this one means this one is bigger, this one is smaller because it's pointing to the smaller. The point goes to the smaller. The mouth is open to the bigger. So that is a greater than, that is a less than symbol. Then you have some think it through questions and some more principles. Principle 4, lines equal to the same quantity are equal to each other. The whole is equal to the sum of all of its parts. So if I've got a line, and it's got from A to B to C to D, that whole line is A plus B plus C. All of those go together to make that line. That whole is equal to the sum of its parts. Principle 6, the whole is greater than any of its parts. The whole thing is greater than just this. The whole thing is greater than just this, or just this, or this. It's a whole, all right? Principle 7, if equals are added to equals, the sums are equal. So in other words, if I have another line just like that, and I have A and B and C and D. If I add A and B of this one, it's going to equal A and B. This is going to equal that. If these were equal, then when I add them, they're going to be equal. And if these are equal, when I add this, it's going to be the same as when I add that. That's all that principle means. And the last one, if equals are subtracted, the remainders are equal, which means if I take this one off there and this one off there, what I have left is the same. If I take that off and that off, what I have left is the same. Simple stuff. If they're equal to begin with, then as long as we're adding and subtracting things of equal size, it comes out the same. Principle 9 on the same page, on the next page, doubles of equals are equal. So if I have a line and I double it, I have another line and I double it, they're equal to each other. If I cut them in half, they're the same. So if I've got this line and this line, if I make this one twice as long and this one twice as long, they're going to be equal. If I cut it in half, the halves would be equal. And the last one, if the first of 3 quantities is greater than the second, and the second is greater than the third, then the first is greater than the third. Because the first is bigger than the second, second's bigger than the third, that makes the first bigger than the third. And they give you examples of that, line number 13. And all these things, 1 through 13, they're just showing you how the principles work and giving you a chance to show how the principles work. So it says on number 1, think it through on page 8. Represent by a line each of the following expressions in which A, B, and C represent line segments. such as A is bigger than B and B is greater than C. So you get to draw these lines. 2, take any line AB and divide it by any 2 points into 3 parts and label them X, Y, and Z. And they've done it for you. You can do it on your paper. 3, show how exercise 2C illustrates principle 4. All right, the lines equal to the same line are equal to each other. What statement made in answering exercise 2B illustrates principle 5? In exercise 2, compare the lines represented by X plus Y and AB. So you're just looking at these examples and answering the questions. Those are just extra credit. The real work is exercise 1.4 on page 9. There's 4 questions. You will do those on your own paper. The Think It Through is just getting you to understand the principles and the drawings. Now you're ready for the very first quiz. It is an open book quiz. It's in your notebook. It says quiz 1, sections 1-1 through 1-4. There are 10 questions. You may do that in class. Turn it in the bin in the back that says geometry. 2 flat surfaces intersect to form a what? A flat surface is a blank. You may answer those. You may use your book. Now we're ready for section 5 and 6, and you are done with the first week. 1.5 is the angle on page 10. An angle is the figure formed by 2 straight lines drawn from the same point. So an angle would be, here's a point, and you have 2 lines drawn from the same point. This is an angle, all right? You have several examples of angles. Usually an angle is like this, and it's named. That would be angle A, or sometimes it's named on the outside. They've given you an angle. They also have an angle that's got A, B, and C, which is just showing the different points on that angle. Equal angles. 2 angles are said to be equal if they can be made to coincide. That means they're the same size. Bisecting of the angle is just cutting it in half. That's a bisection of the angle. If you cut it equally in half, then each of these should be equal, and they should each equal half. So if this was a 30-degree angle, each of these would be 15. 15 and 15 gives you the whole 30. The line through the vertex of an angle, which divides it into 2 equal angles, and this is the vertex where it started. So when you cut that in half, that bisects it into 2 equal angles. And then they have exercise 1.5, just gives you some practice using the angle. There are 8 of those. You need to do that assignment, 1.5. And last, we have 1.6, common angles. We have seen that the size of an angle depends on the amount of rotation necessary to bring the line from the position of one side of the angle to the position on the other side. The line then generates the angle. All that means is the angle is how far it is between this line and this line. They could be really close together like that, which is a small angle. They could be really far apart like that, which is making a really big angle. Either one will work, right? Paragon. When the generating line makes a complete revolution, the angle formed is called a paragon. It's another name for a round angle, which is a circle. Basically, if this line went all the way around and back before it stopped, it made a circle, which is 360 degrees. All right? Or it could do a straight angle, which is basically a straight line. If we went halfway, we now have a straight line, and that's 180 degrees. We have adjacent angles, when 2 angles have the same vertex and a common side. And there's a picture of that. But an example would be right here, where we cut this angle in half. These are adjacent angles. They have the same vertex, and they share one leg. Okay? The top of this one and the bottom of this one are shared. Those are adjacent angles. They're next to each other. And then we have a right angle. A right angle always forms a 90 degree, and we usually do that, a square, instead of the circle. Lets us know that this is a 90 degrees, all right? It's 90 degrees, especially a fourth of a circle. That one would be 90 degrees. That would be 90, and that would be 90. Those are special angles. It's called a right angle. Perpendicular lines, when two lines form right angles. So these would be perpendicular lines, because they form a right angle to each other. These would be perpendicular. These would be perpendicular. When two lines form right angles, they're perpendicular. All right? The point which the lines have in common, which is this one, it's called the foot of the perpendicular. An acute angle is less than right. So if it's less than 90, any angle that would be between these two, any angle between there, is called acute. That means that the angle that we're talking about is going to be less than 90. Obtuse is anything that's bigger than 90. Over here, obtuse. Acute, less than. Obtuse, greater than. Reflex angle is an angle greater than a straight line, but less than a paragon. So this is 180, so it's got to be bigger than 180. It's got to be greater than 180, but it's got to be less than 360, which is all. So it's going to be any angle in here. And again, these are just vocabulary words. Acute, obtuse, reflex, and oblique. Oblique angle is an angle other than right or straight. Acute angles, obtuse angles, reflex angles, oblique angles. Lines which have the position of the sides of any of these angles. Lines which are not perpendicular or parallel are called oblique lines. And then we have some practice doing some questions with vocabulary words. And the last section, special pairs of oblique angles. Let's see if they do 1.7 this week or if it is next week. Week 1 went through 1.5. We don't start till 1.7 until next week. So we have covered all of 1.1 through 1.6. If you have any questions, ask Ms. Tracy or see me Saturday between 9 and 12 here at the classroom. Or you can text or call me in the evenings if you need to ask a question about any of these. All right, that's it for week 1 geometry.